Good evening, everyone. Am I loud and clear to all of you?
Yes, sir.
Yeah. Just one sec. All right. So just 1 minute. We're gonna start the discussion. In the previous class, we have discussed about the thermal definition as well as the temperature scales, right? Now, in this class, we're gonna discuss about the thermal expansion of solid. We're gonna first deal with solid, then I will come to liquid and gas. Okay, because for liquid and gas, we don't have uh, shape and size, but we have volume, right? Because the liquid and gas can take the shape and size of a container. So thermal expansion of solid. Now, guys, all of you know the basics that the solids are rigid because of the strong intermolecular forces, right? Now, what will happen if we heat a solid? Suppose we have a rod and the length of the rod is L and the temperature of the rod is T1. Now, if I'm giving the heat, let's say heat is Q, what will happen to the length of the rod?
So the length will increase.
The
Sir, it
length
will expand.
will expand. Now we have to think why it will expand. Because when we give the heat, the molecules will start vibrating, right? Because of the extra thermal energy. And when they start vibrating, they'll start losing their equilibrium position. And because of that, there will be a slight or significant change in length depending upon how much heat we are giving.
Sir, excuse me.
Yes, Bhavish?
Sir, can we say that the electrostatic force between the particles will become less?
I won't say electrostatic force will become less because it will become less once the particle or molecule will move from their position. Okay. So obviously, if they until they are not displaced, the electrostatic attraction won't change. But once they get displaced, obviously the force will reduce. Okay.
Okay, sir.
So the first effect will be since we are giving energy, the molecules will get excited. So they will start moving away from each other. And obviously, resultant to that, the distance will increase and the attraction will decrease. All right, so here the length becomes L plus delta L. Now, since we are talking only about length, this is called the linear expansion of solid. What we are calling this as linear expansion of solid. Okay. Now, just I want all of you to pay your attention on this delta L value and let me know on which factor it should depends on. The change in length. Obviously, it will depends
So
on
the
heat.
temperature,
Sir, the amount
means
of
the
heat
heat
which we give
supply.
to it.
Yes, it will depend on the amount of heat which will give. And can I say the amount of heat Q? Q is the heat given to the rod. Will be directly proportional to its length. because smaller rod will require smaller heat for the same rise. Bigger rod will require more heat because it has more molecules. Is this point clear to everyone?
Yes, sir.
All of you, are we clear with this? More the length, more the heat requirement.
Yes, sir.
So, and more the heat requirement, more the expansion. It all related, right? Okay. It also depends on what Bhavesh pointed out, rise in temperature. If you only want to rise the temperature by 10 degree Celsius, you have to give lesser heat for the same length of rod. If you want to increase the temperature by 50 degree, you have to give more heat. So more the rise in temperature, more the heat required, and more the heat given means more the change in length. Is this point clear to everyone? Delta T is basically rise in temperature. Okay, I'm going from very basic. I'm not using direct formulas. I'm not, because
Can you please explain that rise in temperature part once again?
yeah, but for rise in temperature, you just imagine you have two rods. Let's take the length equal to make it simple. So you have two rods of same length. One rod you have to give rise only for 10 degree. Means if it is 20 degree, let me take one example here. This is rod A and this is rod B. I have taken approximately same length. Here from 20 degree, you have to go to 30 degree. So you're giving some heat, Q1. And here from 20 degree, you want to rise it to 70 degree. You're giving heat, Q2. Now guys, use logic and tell me which heat will be more.
Q2.
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 Abhishek, you got the point?
Yes, sir.
So more the rise required, more the rise in temperature, more the heat given. And more the heat given, more molecule will try to expand. So more the expansion will be there. Okay.
Okay.
All right. So if we combine these two, okay, here is what we're gonna do, because in physics, we will take the law, we will take the proportionality, and then we will replace it by a constant. And this is not the first time you are doing this. You are doing this from Ohm's law onwards, or even before that, right? So delta L equals to, it depends on two factors. So I will replace the proportionality with an equality and I will put a constant here, alpha, multiplying the two factors on which it depends. Now, obviously, alpha is constant, and this constant is called coefficient of linear expansion. Now, alpha, neither, just like resistance, you guys have learned about V equals to IR. R doesn't depend on V, R doesn't depend on I, it only depends on the material length and area. Similarly, on which factor alpha will depend? Alpha will depend on material. Okay, you take 1 centimeter of that material or 100 centimeter, alpha will remain same. So it's a constant. So this is the formula we got it for linear expansion. Is this clear to everyone?
Yes, sir.
Are we clear with this,
Yes.
guys?
Yes.
All right. So now let us take another example. Instead of a rod, we will take, we'll take a rectangular plate. Or let's take a square plate, doesn't matter because both will work same. So we have a square plate, L. Now, before we move to this, let me tell you about alpha. Alpha general value is in the range of 10 to the power 5 to 10 to the power minus 5 to 10 to the power minus 6 per degree Celsius. This is the actual value of alpha I'm telling you. So this is not a very large value. Okay. And if this is alpha, then obviously alpha square will be in the range of 10 to the power minus 10 to 10 to the power minus 12. Correct? Simple maths. Now, why I'm telling you this? Because you guys till now have not used the value of alpha, so you have no idea. You just know that it's a property of a material. But once you know the value, you will understand that the value of alpha is very small and the value of alpha square or alpha cube is even smaller. So with respect to alpha, you can neglect alpha square very easily. Now here, this is having temperature, let's say T1. And from T1, we have increased the temperature by delta T. So obviously both length and breadth will increase, right? So this will become how much? This will become L plus delta L, and breadth will also become L plus delta L, correct? Now
Yes, sir.
here, what Bhavish, you had any doubt?
No, sir.
Okay. Now we know that delta L, we have just seen that delta L can be written as alpha L delta T. Simple. So what was the initial area? Initial area was length in side square, so L square. This was the initial area. And what is the final area? Final area is L plus delta L whole square. Now I'll take L common. So if I take L common from a square, it will become L square. What I left with in a bracket? 1 plus delta L by L whole square. Guys, till now, any doubt? Everyone clear? Because I'm doing derivation, I'm not giving direct formula. So I want all of you to be on same page. So are we clear till now? The moment I will derive for this, for volume, you will get it by your own. So is this clear how I've written it?
Yes, sir.
Please explain this, that last part of this derivation.
Beta, I have just taken L common. So from here, L is out, so 1 is left. Delta L by L, because there was no L, so I have multiplied and divided by L and taken the L in the numerator as common. Since L is coming out from something of square, so that's why outside will become L square. Clear?
Like what happens to 2L delta L? I want to know.
Where 2L?
Like when you expand this formula, we'll get 2L.
Wait. Now we'll do that. I'm not expanding. I have till now whatever written, that much is clear now. I'll explain. Okay, so delta L is what? Alpha L delta T. We'll put it. And L square is nothing but initial area. So we'll put the initial area and this is the final area. What we are getting here? 1 plus, instead of delta L, what we'll put? Alpha L delta T. L and L will get cancelled. Alpha L delta T upon L. So L get cancelled and the power is still 2. Now guys, tell me one thing. Alpha value is in the range of what? 10 to the power minus 5 to 10 to the power minus 6. Correct? This is I'm telling you for this material like steel and all. And real values. Delta T will be maximum what? 20 degree change in temperature, 30 degree, 40 degree, 100 degree. Right? 100 degrees still 10 to the power 2. If you multiply alpha with delta T, alpha is in the range of 10 to the power 5 to minus 5 to 10 to the power minus 6. Delta T can be maximum 100 or 200. So can I say that alpha delta T will be still quite less than 1?
Sure.
Is this part clear to everyone?
Yes, sir.
All of you?
Binomial expansion.
Yeah, very good, Adit. I will come to that, but is this clear to everyone? He understood where I'm going. Guys, do you
Why
remember
will
in
delta t be less than 200?
Yes.
I'm saying if you are increasing the side, you will keep the melting point in your mind now. So 100, 200 is the maximum change in temperature that we will use in the thermal expansion, right?
Yes, sir.
So 200 into 10 to the power minus 6 still is still less than 1, quite less than 1, right?
Yes, sir.
So that's why I'm taking this assumption. Okay. Now, guys, all of you remember in basic maths, I told something about binomial expansion. That 1 plus x to the power n, if x is much less than 1, can be written as what?
1 plus nx.
1 plus nx. Is this clear to everyone? Then what I can write it here? The final area will be written as initial area 1 plus power is 2 alpha delta t. Now, what I will do is I will take this 2 alpha and I will put it as beta, just to make it same as what we have written for linear expansion. Now here it is not linear expansion. What kind of expansion we are having here? Linear or aerial?
The area, surface
Aerial.
area.
So what we should call beta as?
Coefficient of aerial expansion.
Yes, coefficient of aerial expansion. So here change in area will become beta into initial area into delta t. Because when I will open the bracket, initial area will multiply with this, and this is the factor which we have added. So A final can be written as A initial plus delta A. So guys, is this making sense to you that aerial expansion, linear expansion was taking only in one dimension? So that's why only alpha comes in the equation. Aerial expansion was taking in 2 dimension, length and breadth. So that's why 2 alpha comes in the equation, which we replace by beta. If I'm going to ask you the third type of expansion, which is called volume expansion. Because I have said 5 minutes
Sir,
ago.
could you please scroll up a bit once?
Yeah, beta. Is it fine?
Yes,
What is the
yes.
expression that you have
Sir,
written below?
What beta, Vijay?
The expression that you have written below, that symbol, what I'm.
This one,
Yes, sir. So like LHS with symbol I have written below.
delta.
Okay, sir.
Delta
Sir,
means,
could you once again tell the value for alpha? It's 10 to the power minus 6 too.
minus 5 to minus 6 beta.
Okay, thank you.
Okay, anything else? All right, coming back to what I was going to tell. Linear expansion, 1 dimension. Aerial expansion, 2 dimension. If I take a cube of length L, obviously it's a cube, so we will have the initial volume as. Now I'm going to raise the temperature of the cube from T initial plus delta T. Guys, could you make a guess and tell me what should be the final equation without doing anything? V final.
So V plus V initial,
Sir,
and then we
V
will have
final
some
will be
other
1
constant.
plus gamma del T.
Can I say that it should be something like V initial plus delta V, change in volume, where
Yes,
delta
sir.
V will be,
And
because
we will have something in 3 alpha term.
yeah, correct. Because here we have length, breadth, and height. So we're gonna multiply L plus delta L, L plus delta L, and L plus delta L. So it will become L plus delta L to the power 3, correct? And again, we will use binomial expansion, so that 3 will come in multiplication. So 3 alpha V initial delta T. And this 3 alpha can be replaced by something called gamma. And obviously we will name it as coefficient of what type of expansion we are having here? Volume expansion. Guys, I'm going to write it all the full derivation, but is this expression making sense to all of you? Because logically you can connect.
Yes, sir.
All of you, are we comfortable with this?
Yes, sir.
Yes, sir.
Okay. Everyone, please give me a thumbs up, those who have not unmuted them. Are we clear? All right. So what we're gonna do is simply we're gonna take at T plus delta T temperature, the length will become L plus delta L. So the new volume will become L plus delta L to the power 3, which can be written as L cube 1 plus delta, delta L by L to the power 3, which will approximately equals to V initial 1 plus 3 alpha delta T. So I hope there is no problem in this. So this is the final volume. Is this clear to everyone?
Yes, sir.
Yes, sir.
All right. So this is how we're gonna solve the questions related to thermal expansion of solid, liquid, or thermal expansion of solid in linear expansion, aerial expansion, and volume expansion. Okay. Every material expands, we'll come to that, the abnormal behavior of liquid. But before that, let me take one question. You have a steel scale. Calibrated means the temperature at which it will give the correct reading. Okay. Calibrated at 15 degrees Celsius. What is error in reading 60 centimeter, reading of 60 centimeter at 27 degree Celsius? Alpha of steel equals to 1.2 into 10 to the power -5 per degree Celsius. Please try to solve this. Calibrated means it will give the correct reading at 15 degree.
Sir, what you have written after error in?
Error in reading of 60 centimeter at 27 degrees Celsius. Himanshu, correct beta. Shri, correct. Gaurangi, I think there is some problem with the decimal. Aditya, correct beta. Bhavish, correct. Manushri, correct. Good. Here, first you have to understand they are talking about error. So error means delta L. Obviously, steel is a metal, so it will expand. So at 15 degree, it will give the correct reading. At 27 degree, there will be some expansion. So whatever expansion is there, that will be the error. So delta L equals to error in reading. And what is the formula for delta L? It is L, how much length you are reading? 60 centimeter. So 60 into 1.2 into 10 to the power minus 5. And how much is the rise in temperature? I think 12. So if you multiply all this, I think you'll get 0.00864 centimeter. Is this clear to everyone, first of all? Because I want to discuss a bit more regarding the steel scale. But are we first of all clear with this, how we got the error? Everyone?
Yes, sir.
Why there will be error is clear, because calibration means it is calibrated for a specific temperature. If we change the temperature by increasing or decreasing, there will be change in value. Bhavesh, you want to ask something?
No, sir.
Okay. Now I have a question for you all. Okay. Let's say I have a length of a
Excuse
material.
me, sir.
Yes, beta.
Sir, I didn't really understand why we took the error and as change in length.
Because let me again try to explain it. Arinja, right? Suppose you have these
Yes, sir.
divisions on your scale, right?
Yes, sir.
So each unit is 1 centimeter, but this is at any specific temperature, right? So let's say at what temperature you have taken or designed your scale to use? 15, correct?
Yes, sir.
Now just Peter, think about it. When you use the same temperature at 30,
Oh,
will
sir,
this...
wait, I got it. Yes, I understood it. Yes.
Okay, good. Now guys, let me continue with this because I wanted to ask one question, but before asking, I want to clarify this particular thing to all of you. So when I'm using this temperature to 30 degrees Celsius, what will happen to the division of this? Will it remain at 1 centimeter or it will
Sir, it will
adjust?
change.
So it will increase
It
from
will
1.
increase. Actually, it will become
Increase.
1 plus delta L. And here delta L will be, because I have taken 1 unit, it will be 1 centimeter into alpha into delta T, which is 15 degrees Celsius. Is this point clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Now guys,
Yes, sir.
earlier, if I was measuring a body which was exactly 1 centimeter, now if I measure the same body, assuming that the body has not changed with temperature, will I get more length or will I measure shorter length?
More length.
Think and answer.
Can
Can you repeat the question?
There is a body whose measurement I have taken at
So
15 degrees.
shorter because
It came out as 1
divisions.
centimeter. So when I measure it again at 30 degree, the measured value, okay, the actual value is 1 centimeter. The measured value will be more than 1 centimeter or less than 1 centimeter?
Still less
Sir, it
than
would be
1
less,
centimeter.
Less
right?
than 1
Because
centimeter because the division has increased.
Okay, beta, just 1 second. Let me again write it properly so that all of you should understand clearly. Measured length equal to actual length. Is this clear to everyone? At 15 degree? Because the calibration was at 15, so measured length and actual length are same, correct? Actual length is not changing. Measured length will change. Is this point clear to everyone? Now, can I say at 30 degree, measured length will be less than actual length? Is this clear to everyone or not?
Sir.
Yes, sir.
Why the measured length has decreased? Because you are measuring with the help of steel scale. So whatever the division of steel scale is there, that division will give you the reading. And due to heating, the division has expanded. But your body length is remains same. So now earlier what was used to be 1 centimeter, now it is less than 1 centimeter because one division has shifted towards right. So now when you measure the same body, you are getting lesser value. So what is the error here? Your error is the delta L. Is this point clear to everyone?
Yes, sir.
So let's make a basic concept for a steel scale because I'm telling you guys, I have seen enough student who knows the concept, everything's clear, but when you start asking in detail of these things, they start getting confused. So that's why I'm discussing. I know that you guys have answered the first question, but I'm discussing the basic points which is required here. So can I say that, let's make a concept that if we increase the temperature from calibration temperature, our measured value will be less than actual value. So to get the correct value, so to get the correct length, what we should do, we should use the measured value plus delta L. Is this clear to everyone? Actually, correct length and actual length is same. So is this point clear to everyone?
Yes, sir.
Yes, sir.
And the reverse is obviously quite logical, so everyone will understand. When we decrease the temperature, the reverse will happen. The divisions will come closer. So in that case, measured value is actually more than actual value. So in that case, to get the correct reading or correct length, we should subtract delta L. Guys, are we clear with this?
Yes.
Okay. Everyone clear? All right. So let me share one question with you all. Can everyone see question number 6? There are two parts. All of you, is question number 6 visible on your screen?
Yes, sir.
Yes, sir.
Please go for it.
Sir, which question? Sorry, I couldn't hear.
So what is the value of alpha?
Value of alpha, just one sec. You can take 1.2 into 10 to the power minus 5. Wait, just wait. Let me check and give.
Sir, alpha would be 2.3 into 10 to the power minus 5 per degree Celsius.
Wait. For steel, it is 1.2 into 10 to the power minus 5. For aluminium, I have to check. What, Bhavesh?
Sir, alpha would be 2.3 into 10 to the power minus 5 per degree Celsius
For which material you're telling?
for aluminium.
From where you have got the value? You've checked on internet or?
Yes, sir.
Okay.
So can I ask a question?
Yeah.
Sir, for the sixth A1, will we take L as 88.42 or will we take L plus delta L as 88.42?
You are measuring it at 35 now.
Yes, sir. So
That is the measured length. Here I have written now this. This is what is given to you.
okay, got it. Then I got it.
Guys, for just what he said is correct. I have checked it. For aluminium, you take alpha as 2.4 into 10 to the power minus 5. And for steel, I have already told in the previous question, it is 1.2 into 10 to the power.
Sir, it would be okay. We will take 2.3 or 2.4.
It will be fine, but if you have already taken, so don't need to change it. Because anyway, in the question of JEE, it will be given. So you don't need to worry about it. And neither you need to remember it. Bhavesh, fine. Isabel, correct, beta. Arinjia, correct. Himanshu, in which unit you have given me the answer? I didn't understand.
Sir, meter.
Okay.
So in these questions, the value is coming a very complicated one. There can we use any kind of approximation to get the answer quickly
Uh,
to make the calculation because the calculation dividing it takes a lot of time. So can we approximate anything?
if you want, you can round off up to 2 decimal. Gaurangi, correct, beta. Shri, you have calculated delta L for the first part.
No, sir, I'm calculating that itself.
That one only you are saying that it's getting very
Yes, now I got it because I took the two decimal, the value. I'm trying with that.
okay. Arinjia correct, Bhavesh correct. Gaurangi, I think there's a slight problem with the answer. You have to add delta L with the measured value.
Yes, so that's what I did.
Uh, Gaurangi, now it's fine.
Sir, these questions are from DC Pandey.
Yeah. Okay, let me take it here. So the first part of the question, it's asking that correct measurement is taken at 5 and the reading is taking at 35, right? So that is the change in the temperature, and the length which is getting measured is given. So they're asking for delta L. So it's 88.42 into 2.4 into 10 to the power minus 5 into 30. Which I'm sure all of you have already solved it, right? So this is approximately, it's coming as 0.064. Now, what is the second part of the question asking? If this aluminum rod measures a length of steel as 88.42 at 35, what is the correct length of the steel? So basically, they are asking for correct length, and at higher temperature, we have already done this formula. Correct length equals to measured length plus delta L. So we'll simply use it. 88.42 plus 0.064. That's approximately, it will come as 88.484, I think, centimeter. Okay, concept wise, guys, are we clear with this, everyone?
Sir, I had a doubt. In the question, it's saying measures a certain distance as so that is the original length.
Where, beta?
So means here I got confused.
No, this
Measures a
is
certain
I'll
distance.
tell you. This is the measured length.
Yes, sir.
Measured a length of steel as.
Yes,
Okay.
yes, sir. So
At
if that
30.
is the measured length, how are we put means in the formula we have actual length. So
Wait, I have taken this length. At this length, this is the error we will get. Okay, 88.42. First of all, understand this for the first part. Got it?
so means for the measured length, what is the error?
For the
So for the measured length, what is the error? That is what we are calculating.
yeah, here
Okay, okay, sir.
got it. 88.42 is given as the measured length at 35 degree. So we
Yes, sir.
already know the error now.
Yes, yes.
Okay.
Okay.
Shri, I will give some more question in the group. I will share for all of you. Please go through them, okay? So that you will have a better command over it. Because these questions I'm telling you, if we ignore it, it will be very confusing. So I hope now, guys, you have got the basics of this scale measurement thing. Are we clear with this, everyone?
Yes, sir.
Yes, sir.
Okay. Let me take one more question. Just for the understanding, if we are increasing the temperature, our error is positive or negative? Obviously positive, because delta L is increasing, right? And why I'm telling it, because there might be a question asked in JEE where they will give the change in temperature and they will give the answers in plus or minus. So we should be very clear that whenever we are increasing the temperature, the error will be positive because the final length will be more than initial length. And when we are decreasing the temperature, the error will be negative. Is this point clear to everyone? Because error is change in length by original length. So delta L is positive or negative, that will depend on the rise of temperature or fall in temperature. Are we clear with this? Because mostly we use delta L as alpha L delta T. We tend to ignore the sign. So is this clear to everyone that what I said about the sign of the error? If nothing is given, every options are positive, no problem. But if they have given positive answers also, negative answers also, so we should keep the sign as well in mind. Clear? So go for question number 7. And try to get the answer with proper sign. Isabel, correct, beta? For steel, do I have to tell the value of alpha or everyone is clear?
Clear, sir.
No, sir,
1.2
clear.
into 10 to the power minus 5. Bhavesh, your answer is correct. Just tell me plus or minus in the message. Shri, correct, beta? Aditya, check the power. It's look weird. Bhavesh, we are decreasing the temperature. Himanshu, correct, beta? Aditya, no, it's not that. Yes. Varangi, correct, beta? Abhijay, correct. Okay, so the question is quite straightforward. The calibrated temperature is 20 degree and it is used at -10. So delta L by L with sign, if I have to put, I'll put minus 1.2 into percentage, so obviously multiplied with 100. So 1.2 into 35, 20 minus 15. This is the change in temperature or drop in temperature into 10 to the power -3. This is coming as approximately 0.042%. Okay. So this is the answer for the 7th question. Okay. Now I just want to discuss one small concept.
Why will
Here.
it be, so why will the answer be negative?
Because we are decreasing the temperature, so the rod will shrink. So the final length will be lesser than the initial length. So change in length will be negative. Okay. Guys, I have a very simple question that we have a beaker. It is made up of any material, and inside beaker there is a liquid, right? Obviously, liquid expansion will be more than the solid expansion. It's completely filled. We are heating, just like we have kept a liquid in a beaker and we kept it over burner. So we are heating. So obviously both will rise to the same temperature. Let's say this volume is V0. Now, how can we calculate the overflown volume? Here, if you pay attention, liquid is boiling, means expanding. Same time, your solid will also expand. But who will expand more?
Liquid.
Liquid.
Obviously,
We
liquid.
can subtract the expansion of the
Yes.
beaker from the expansion of liquid.
Very good. So we're gonna do this. Delta V of liquid minus delta V of solid. So we can say, and keep in mind, in this question, I have taken both volumes as same. It's not necessary that every time volume will be same. It will depend on the question. Here I have taken both volume as same, as means the beaker was completely filled. So for this question, our answer will be this. Is this clear to everyone?
Yes, sir.
All of you, are we clear with this? Now, here, this gamma L minus gamma S means expansion coefficient of liquid minus expansion coefficient of solid. We call it as gamma apparent. Okay. So I'm going to start the next class exactly from here. Guys, are we clear with whatever I have discussed in this class? Please tell me first.
Yes,
Everything
sir.
is clear?
Yes.
I'm going to share some of the questions for practice in the group for thermometer related questions as well as questions on thermal expansion, whatever we have covered so far. And please go through those questions, and whatever doubt will be there, I'll take it in the class. So are we now comfortable with this topic? As I said, from this onwards, I'm going to take in the next class. All right, everyone. Thanks for
Yes.
joining.
Thank you, sir.
Bye-bye. Take care.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.